So here's another problem on calorimetry. This is a little bit different now. So here it says that we have a 2.29 kilograms of iron skillet. The specific heat is given to us and it is heated to 375 degrees Celsius. And then 453 grams of water at 11.5 degrees Celsius is added to the skillet. Will the water boil? Okay, that is what the question is. And excuse me, I have to change one unit here. This should be Fahrenheit. So then will the water boil? So which means if you're pouring water into a hot iron skillet, is it going to boil? That's the question. So our first thing that we have to do is make sure that our units are all good. Okay, so that's why I have to change those units because I wrote the problem wrong. But in any case, so for degrees Celsius, okay, that you need to know for 375, converting that is 5.5 over 9. Multiplied by, and then 375 minus 32, and this is equal to 191 degrees Celsius. Okay, so that is the conversion for that, and then of course the 2.29 kilograms is equivalent to 2.29 times 10 to the power of 3 grams. Okay, so that is our unit conversions. Then let's look at the problem and how we're going to solve it. Okay, so which means that you have an iron skillet and you're pouring water into it. Okay, so there is a certain temperature of the iron skillet which is at 191 degrees Celsius. The water here is at 11.5 degrees Celsius. Okay, so which means that the skillet is going to give the energy to the water. Okay, and that's why the question is the water going to boil or not? All right, and so which means that we need to talk about the energy transfers over here. This is the kind of problem we did in class also regarding hot water and cold water, if you remember. So we're talking about the energy transfer between the skillet and water, which means that whatever amount of energy is given by one should be absorbed by the other, okay, and vice versa. All right, so which means that we can start with something like Q. The energy that is of iron that it has is going to give it off to water. Okay, so which means that this should be equal to 0. So either you can put those both on one side and say this is all equal to 0 because the complete energy transfer should be equal to 0. So which means that by the time you transfer the energy from one to the other, it should be all 0. Okay, and so let's go ahead and set this up. The way we do this is Q, and then of course the Q for iron and the Q for water over here. So which means that MS delta T, this is all going to be for iron, and this is going to be equal to negative Q, which is then the negative of MS delta T for water. Okay, so that's what it's going to be. So let's go ahead and plug in all the numbers that we have. So for iron, the mass is 2.29 times 10 to the power of 3 grams times the specific heat, which is 0.449 joules per gram degrees Celsius, and the delta T. Now we don't know the final temperature, okay, of the skillet because that's what we are trying to calculate. Okay, and so the initial temperature is 191 degrees Celsius, and this is all equal to the mass of the water, which is 453 grams of water. The specific heat of water is again 4.18 joules per gram per degree Celsius, and then of course the T is T final. We are trying to calculate the initial is going to be 11.5 degrees Celsius. Okay, so that's our calculation that we have to do. So then 1.03 times 10 to the power 3 joules times, and this is going to be T final, minus, sorry, no bracket, let me cross that out. It's 1.03 times 10 to the power 3 joules, and this is going to be TF because we open the brackets up. So all of this multiplied by TF, and then minus 1.96 times 10 to the power of 5 joules, and we do the same thing on the right hand side, which is multiply these two numbers and then with TF, and you end up getting minus 1894 joules per degree Celsius, TF, plus 2.18 times 10 to the power of 4 joules, and then there is degree Celsius here also, keeping the units in check. So then we calculate for T final, okay, and that the T final, after doing all the math, is going to be 74.7 degrees Celsius, okay. And so once the T final is calculated, you know that the water will not boil. So the key thing here to remember is that the energy transfers are complete, okay. So if you have something giving off heat, then something is going to be absorbing heat, okay, and so that energy should be equal to 0, okay. That's the key thing over here to solving this problem.